part of it is pretty straightforward. It's just some definitions. Just want to make sure that I hit recording there. I don't know if I hit. Yep. So we're going to talk a little bit to start off about polynomial functions. And that's kind of a redundant statement because all polynomials are functions, and we'll talk about that in a second. So polynomials. You've worked with quite an extensive group of polynomials this far in your high school career. Grade 11, grade 9, you spent a lot of time with linear functions, which is a polynomial function. Grade 10, you spent a lot of time with quadratics. And then in grade 11, you did some more with cubics and trigonometric. So an example, not trigonometric, sorry, it's not a polynomial function, I don't know why I said that. An example of a polynomial function is I can use f of x or I could use y. They're interchangeable, mean the exact same thing. It just means the dependent variable of the outcome. And then you'll have real number coefficients. Coefficients are just a fancy word for saying the numbers in front of the letters. And then you'll have a variable, usually we use x, and then you'll have exponents. What makes it a polynomial function is the exponents have to be positive full numbers. Okay? If it's any other exponent, then it's not a polynomial. Okay. This polynomial is in standard form. It's in standard form because it goes from the highest exponent down to the lowest exponent. In fact, to one where it doesn't even have an x. So that's what it means to be in standard form. So this is a specific polynomial function. What I want to talk about is the function, the polynomial function in general. So in general, so whenever we do things in general in mathematics, this is where things get confusing because you have to introduce letters. Okay? So in general, a polynomial function can be written like this. I need something to represent the coefficients, so I'm going to use the letter A. I need something to tell the difference between my A's, so I'm going to put a little subscript, and I'm going to call this guy n. Okay, so that's just saying the first coefficient. And then x to the exponent n. And then to get to the next one less than n, right, then that'll be 1 less. So to get to the next coefficient, I'm just going to subtract 1. And remember that to put it in standard form, the highest exponent has to be the first one, and this is the first one, n's higher. Like, so if n was 8, then the next guy here would be 7, and so on. But every single exponent does not need to be represented in a polynomial function. Like this guy here is missing a 2, that's fine. And then you go all the way down to where you get your single term for x, and then you get to the last term that doesn't even have an x. So just some names. When the polynomial function is given to you in standard form, so standard form from the highest exponent listed down to the smallest exponent, then the coefficient that is in front is called the leading coefficient. The highest exponent in the polynomial, which is always going to be the first one here when you have it in standard form, that helps you find out the degree of the polynomial. So whatever the exponent is the degree of the polynomial. So my first example, the degree of this polynomial would be 4. The last term, the one without the x, is called constant term. So in this case, n is the degree of the polynomial. So all polynomials are functions, so it's kind of redundant to say polynomial function, but you can say it. Okay? So n is the degree of the polynomial function. So you should be able to identify the leading coefficient the degree of a polynomial and the constant term when I give you a polynomial function. So let's just practice doing that. Example, determine, or say given f of x is equal to 6x squared minus 10x plus 8x to the 4 minus 6. Determine, first of all, put the polynomial into standard form. So putting the polynomial into standard form should be pretty straightforward. You're just rearranging it from the highest exponent down to the lowest exponent. So in standard form, the polynomial would be 8x to the 4 plus the next one is the squared, then the x term, and finally the constant term. B, I ask for the degree of the polynomial. Then the degree of the polynomial in standard form should be very easy. You just go to the highest exponent, you look at it, it's 4, so the degree of the polynomial is 4. The next thing is the leading coefficient. Now, I may ask you on the test to determine the leading coefficient, or I might just put down that symbol, the a to the n. So you have to know that that a to the n means the leading coefficient. So you just look at the number in front, and that happens to be 8. And much the same fashion, if I ask you for the constant term, that just means the number at the end, or I might just put a to the subscript 0. And you need to know that that means the constant term, and in this case, it's -6. Okay, any questions on that? Okay. So when you're given a polynomial function and it's given to you in standard form, it's very easy to figure out the degree, the leading coefficient, and the constant term. It's not so easy to figure out the intercepts. Because in order to figure out the intercepts, what would I need to do to this polynomial? Yeah, factor? I'd have to factor. Okay? Because when it's in factored form, it's very easy to read off the intercepts. So let's talk a little bit about factored form. So a factored form of a polynomial, and again, just so that you realize that x and y are interchangeable, excuse me, not x and y, f of x and y are interchangeable, I'll just use y in this case. So a factored form is, you'll always have a constant term out in front, whether it be 1, but it'll always be something there, and then, oops, oh no, I can do that. So that's an example of a factored polynomial function. And it should be fairly easy to read off the intercepts from this factored form. Anybody tell me what the intercepts would be? Okay, so 2 from here, because you want to know what makes this 0, that'll be 2. 1/3 from here, but the 0 would only be if you had an x there. Okay, so if it doesn't have anything, then there's no intercept. Okay? Okay, so in general, what the factored form allows you to do is to figure out the intercepts very quickly. So f of x is equal to some number k. There will always be some number out in front, and then you can go all the way down. Okay, but it allows you to read off the zeros pretty easy. Okay. So we'll do an example of determining the zeros of polynomial functions. Example, determine the zeros. Okay, so this one I'm not going to put in factored form. We're actually going to factor it because I want to talk about proper notation. So if I give you a function and said, determine the zeros of this function. So like Rebecca said, when it's not in factored form, you have to first factor it in order to put into factored form and solve for the zeros. Okay? So I'm going to factor it. I look for two numbers that, because it's a simple trinomial, I look for two numbers that multiply to 10 and add to 7, which is 5 and 2. Okay? and then looking at this, what are the zeros of the function? Okay. Good. So x is equal to -2, x is equal to -5. If you do this on a test, I'm going to put BF beside your test because it's bad form. What did I leave out? And this happens all the time, and I take marks off it all the time, and I shouldn't need to. Allie? Exactly. You can't solve it equal to 0 if you never set it equal to 0. Seems like something small, but mathematically, it means a lot. You have to set it equal to 0 in order to solve it equal to 0. If you leave out the 0, you're going to lose marks. Okay? Make sense? If it's greater than a quadratic, or it's any of the factoring that you haven't learned up until this point, then usually it'll give it to you in factored form. So y is equal to -3x, 2x minus 1, 3x minus 4. So if I ask you to solve or to find the zeros of this function, then what I want to see on a test, okay, is that you're setting it equal to 0. And then if you're from here, if you go straight to the answers, that's fine. But if you can't, how I get the answers is that this term multiplied by this term multiplied by this term gives me 0. And the only way you can get 0 in math is by one of these guys have to be 0. So you'd say either the 3x minus 1 had to be the 0, 2x minus 1 would be the 0, 3x 4 would equal to 0, and then you solve each one of these. Divide by -3, I get 0. Bring the 1 across, becomes positive. Divide by 2, it's 1/2. Much the same fashion, I get 4/3. So those are my 3 zeros. Okay? So on a test, I want to see that you set it equal to 0, and you can skip right down to the answer if you can get to that. If you can, if it helps you to write out the steps, and do so. Any questions on that? Yes? This guy right here? No. In fact, never, ever in high school change anything to mixed fraction. Okay? So mixed fraction, like a whole number in a fraction, that's elementary school. Okay? Never do that. The only thing you would lose marks for if this worked out to be 8/6 and you didn't simplify. Okay? Any questions on that? Okay, so we've learned so far what the degree, what the leading coefficient, what the constant term is, what a polynomial is in standard form, what it is in factored form. It's easier to read off the factors, the zeros from factored form than it is from standard form, so you have to do the whole factored part. Okay? So that we're going to get on to the next part, which is talking about intervals of increasing and decreasing. So some more definitions. Intervals of increasing and decreasing. Everything in mathematics is read to the right-hand side. So if you're reading a graph, right, then you read it towards the right-hand side. If the function of the graph is going upwards, then you say it's increasing. If the function of the graph is going downwards, then you say it's decreasing. You never read it. You never say something's going up to the left. Okay, always towards the right. So to talk about intervals of increasing and decrease, I'm just going to do an example. So my x and my y axes, and I'll have a function. So that's my function y is equal to f of x. Okay, so at some points this function is increasing, some points this function is decreasing. And what I want to be able to do is I want to be able to identify that. Okay? When a function changes from going down to going up, at the point at which it changes, or from when it goes up to going down, those are called turning points. So in this case, my function is decreasing. Even though this arrow is going up, it's going up towards the left, right? You always read it to the right. So it's coming down, and it's decreasing, and then it starts then it changes at the turning point to increasing, and then it changes at the turning point again to go down to decreasing. So I want to identify the intervals of increasing and decreasing for this function. So what I need to know is the x values where these guys change. So I'm just going to make this up as part of the, we'll say that's 2, and this is positive 2. That's where the turning points are. Okay? For some people on a test and stuff like that, don't do it in your textbook. Okay, well, most of you don't have it. If you do have one, don't write in it. It helps if they color code it. So it's going up to the right. It'll be green. It's going down to the right. It's red. So if I ask you to identify the intervals of increasing and decreasing, I'm talking about what x values, between what x values is it increasing, between what x values is it decreasing. So we'll do increasing intervals. And decreasing interval. So between what two x values is my function increasing? Sure. Okay. So I want to write down the interval between that represents all the numbers between -2 and 2. So what I want to do is x is less than 2 and x is greater than -2. Make sense? Okay. I want to do the intervals of decreasing now. So the function is decreasing on this side of -2, which is all the numbers less than -2. So x is less than -2. And then it's decreasing again after. So x is greater than 2. Because this is a polynomial function, which means it's continuous. Continuous is just a fancy word for saying you can go from one side of the graph to the other side of the graph without lifting your pencil or your finger off the graph. So there's no breaks in it and stuff like that. Okay? We have to include 2 in either one of these intervals. Doesn't matter. So to include it, remember that you put a little equal sign in it. 2 has to be included. I think you don't want to leave it out. Any questions on that? Okay. I use a different way of expressing intervals. Okay? And it's not something I made up. It's mathematically sound. And I use parentheses notation. If I want to represent all the x values between -2 and 2, this is the way that I would write it. From -2 to 2, and then I have to put brackets around it. Okay? So the brackets that I use are a round bracket if I don't want to include those numbers, and I use a square bracket if I want to include that number. So include it. So in this case, I want the numbers between -2 and 2, but I don't want to include them. So I would write that interval like that. What do you think the only problem with this? What does this look like? Yeah, it looks like a point on the graph. But you have to understand when you're talking about intervals that it's interval notation. Okay? To do these guys, we have to introduce positive and negative infinity. So bless you, when a function is heading up to the right, or when you're going to the right on any graph, you're heading towards positive infinity. When you're heading to the left, you're heading towards negative infinity. When you're heading upwards, it's positive infinity. When you're heading downwards, it's negative infinity. So for me to write the numbers that are less than and equal to 2, I need a starting point, which is negative infinity. I go up to -2. I want to include -2, so I put a square bracket around it. Infinity is a number you can never achieve, so it'll always have a round bracket. And then this one here, you're starting at 2, you're including it, you're going up 2, but never reaching positive infinity. This parentheses notation Anybody taking calculus and vectors, it's a lot easier now, even if you're struggling with it, is to get to learn to do it like this. Okay? Because you're going to be doing a lot of the job. On the increasing, because you can't include it in both. Okay, so you have to choose one, and it does, like I could have put it up here. If I put it up here, I shouldn't put it down here. It just has to be included in both. Okay? Any questions on that? Okay, so just practicing writing it in the parentheses notation. So, different example. Say I wanted you to represent this number line in parentheses notation. So, I'm starting at -3. I'm going up to 4. I'm going to include -3. I'm going to go up to 4, but not included, and I want all the numbers in between. So how would I write that in parentheses notation? So the parentheses notation, hopefully is easy. You just need your starting point, you need your ending point, and you put the proper brackets around it. Kyle, you want to give it a shot? What's the starting point? What number? Yeah, what's the ending point?
Would be 4, positive 3.
Well, you tell me. Is it going beyond positive 4? So it stops at 4, right? So am I including 4?
Yeah.
What does a round circle mean?
Oh,
Right, so what type of bracket does it around it? Which one?
oh, rounding it, it's still round.
Right, and if I am including it?
It's correct.
Exactly. So that's what this interval represents. If you really don't like it, you can do this. You can still write x is less than 4, x is greater than -3. You don't have to do the green thing, you can always do this. And if you don't like either of them, you can actually even draw me a number line if that helps. Whichever one suits you the best. Okay. Any questions on that? Okay, so our final example is determining an equation from a graph. So I'm going to give you a graph of a function, and then I want you to tell me what the equation of that function is in standard form. So I'm not going to draw it to scale. So in order to figure out the equation of the function, first thing you need is the zeros of the function. So once you get the zeros of the function, you can put it into factor form. Okay? So you need these points right here. That's -3, that's 1, and that's 5. Once you get the zeros, you can put it into factored form. Okay? Once you get it into factored form, you're going to need to find out that number in front. So in order to do that, you're going to need a point on the function. I'm going to give you the point -3, positive 3 and 48, -48. Okay? Yeah. So I'm going to give you the point positive 3 and -48. So I'm just going to write down every single thing for this, and once you get in the used to doing it, you won't have to write down every single step. So the first thing you do is you write down the function in factored form. Remember, in factored form, it's always going to have a number in front of the bracket. So remember, put that in. That is the number one mistake people make on the first test, is they forget about that k value. So let's go back over here for a second and identify the intercepts. Well, the x-intercepts are -3, 1, and 5. What binomial would I have solved equal to 0 in order to get x equal to -3? John? Right, so that's my first factor. Much the same fashion, I would have solved x minus 1 and x minus 5. Does that make sense where I got those from, those brackets? Okay. So I have it in factored form. The only thing I still need to figure out is my k value. How do I figure out my k value? Yeah, right? Excellent. Okay, so this point satisfies the function. So it's saying when I substitute 3, I should get -48 as my answer. So that allows me to substitute in -48. K I don't know, but all the x's I know is 3. I get negative 48 is equal to k times 6 times 2 times negative 2, which is negative 48 is equal to negative 24 times k. Divide both sides by negative 24, and k is equal to 2. Okay. Once I have that, be careful on the test whether the question, what version you're writing, whether the question says determine the function in standard form or factored form. Because if it says factored form, you write this, and you're done. Because now you have it in factored form. But remember, in factored form, the only thing that you can read off very easily are the intercepts, right? Negative 3, 1, and 5. Okay? In standard form, it allows you to read off the degree, the leading coefficient, and the constant term much quicker. We can do it from this form, and we'll talk about that in a second. But it's easier to do it when it's in standard form. And that's what this question asks us to do. So when you're multiplying, it doesn't matter when you're multiplying the order in which you multiply it. So I'm going to multiply the 2 into the first bracket. And then I'm going to multiply the second bracket out using FOIL, and I'm skipping a step. If you struggle with your algebra, don't skip that step. Okay. Anybody unsure how I got this? I'm just this times that times that times that times that. It's all good? Okay. So then now from here, I'm going to multiply the 2x into there. So I get 2x cubed minus 12x squared plus 10x. So that's 2x times everything. Now I'm multiplying the 6 in. 6x squared minus 36x plus 30. Collecting like terms. 2x cubed minus 6x squared minus 26x plus 30. So from here, it's a lot easier to see that the degree of the polynomial is 3, the leading coefficient is 2, and the constant term is 30. We can get those answers from here. It just takes us a little bit of work. To figure out the degree is 3, how do you think you would do that from the factored form? Yeah. Yeah, 3 x's. So 1, 2, 3 of them, the degree is 3. To figure out the leading coefficient, all you would do is multiply because all the ones in front of the x's make the coefficients. So you just multiply the ones with x's. 2 times 1x times 1x times 1x is 2x cubed. That would give you that. And to do just the numbers, you would just multiply the numbers together. 2 times 3 times negative 1 times negative 5 would give you 3. So you can get the answers. It's a lot easier to read them off in standard form than it is factored form, but you can answer those questions. Any questions? Okay. So, like I've said in the past, I want to save this first, and then after